Welcome to this deep dive explainer. If you are gearing up for your Cambridge AS and A-level computer science exams, specifically targeting that challenging 9618 syllabus, you are in exactly the right place. Today, we are tackling an absolute beast of a topic. We're talking about process management in operating systems. Now, this subject, it's completely non-negotiable. It appears in virtually every single examination series, and it's the kind of topic that separates the average grades from the absolute top tier. But listen, we aren't just going to sit here and read textbook definitions at you. No way. We are looking at this through a highly specific, totally game-changing lens that we call the fashion designer strategy. Think about it for a second. What does a master fashion designer actually do? They don't just grab a one-size-fits-all t-shirt off a rack. They tailor their work to fit the exact, precise measurements of their specific client. There are no loose threads. Every single stitch is purposeful. When you sit down in that exam hall, staring down a massive 9-mark long response question, you have to be that designer. You need to tailor your response to fit the unique context of the question perfectly. To really understand this, let me introduce you to two typical students that examiners see pop up in the grading reports year after year. First, we have Alex. Now, Alex works incredibly hard. Alex has literally memorized the entire textbook. But when the exam starts, Alex panics and just dumps raw, unfiltered computer science facts onto the page, completely ignoring the actual scenario the question provided. Zero analysis. Then there's Sam. Sam gets nervous about the clock, rushes through the paper, and completely misses the specific command word requirements. Both Alex and Sam end up losing massive amounts of marks, not because they don't know the material, but because they didn't tailor their approach. Today, we're going to transform those flawed approaches, tear them down, and give you the ultimate blueprint for perfectly crafted, high-scoring exam answers. Okay, let's dive into our masterclass roadmap for today. First, we'll tackle core principles in unfamiliar contexts. Then, we'll establish a solid procedural framework. After that, we'll break down the deconstruct, solve, evaluate triad, dig into the top examiner warnings, and finally, lock in your ultimate safety net, the method mark strategy. Let's get moving. Section 1. Core principles and unfamiliar contexts. Now, process management really isn't just about memorizing facts like what a process control block is. It's about building a deeply connected conceptual foundation. So I want you to really think about this question. Why is applying these core concepts to unfamiliar contexts so incredibly difficult? Because honestly, this is the main hurdle. The mechanics of process management, things like process states, scheduling algorithms, interrupts, they show up on every single paper. Yet when Cambridge throws in a totally new, complex scenario, candidates freeze up. The root of the problem almost always comes down to command word decoding. This is exactly where our student Sam fails, right? Imagine sitting in the exam and the prompt describes the incredibly complex operating system of a self-driving car that urgently needs to prioritize incoming LiDAR sensor data. The question explicitly says, evaluate the scheduling algorithm used in this specific system. But Sam just skims it, sees the word scheduling algorithm, and immediately starts describing how round-robin scheduling works in a generic desktop computer. Here's the harsh truth. Describing is absolutely not evaluating. An unfamiliar context demands that you stop, take a breath, and identify the unique constraints of the scenario given. You have to decode that command word, whether it is analyze, evaluate, discuss, or describe. You can't just throw textbook definitions at a self-driving car scenario. You have to explain exactly how prioritizing that sensor data prevents a catastrophic crash, and why a specific algorithm is the only logical choice for that exact environment. Moving on to Section 2, the procedural framework. Mere survival in the exam room requires a highly structured, algorithmic approach to your problem solving. Let's talk about algorithmic thinking. It involves step-by-step decomposition, appropriate data structure selection, efficient code implementation, and rigorous testing. When we apply this specifically to process management, what we're really talking about is breaking down exactly how the CPU allocates its most precious resources. It means deeply understanding the queues and data structures like linked lists or arrays that the operating system uses to manage whether a process is running, ready, or blocked. It means evaluating the efficiency of different execution methods under heavy loads. Mastering this level of algorithmic thinking doesn't happen overnight. It takes strategic, guided practice, which is exactly why we break down these complex topics for you step by step. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Now, this 5-step process brilliantly illustrates the standardized sequence for systematic processing. I want you to imagine you're sitting in the exam and you're presented with a highly complex table showing a dozen different process arrival times and their corresponding CPU burst times.
It looks overwhelming at first glance, but if you use this framework, you take control. Step 1, identify key elements. Do a quick 60-second visual scan of the data to extract the core trend. Which process arrived first? Which one is the longest? Step 2, apply relevant principles. Based on the constraints, are you using first come, first served, or are you implementing shortest job first? Step 3, execute the analysis with incredibly clear working. Seriously, map it out, draw a Gantt chart, show the timeline. Step 4, verify your results. Ask yourself, does this total execution time actually make logical sense, or did I miss a context switch overhead? Finally, step 5, present in the appropriate format. By rigorously committing to these 5 steps, you ensure that your answer is custom-tailored to the specific data Cambridge provided. You completely eliminate those messy, rushed errors that cost our student Sam so many valuable marks.
Section 3, deconstruct, solve, evaluate. This is where we introduce the holy trinity of exam success. This triad is the very core of what top-scoring candidates do to ensure their answers fit perfectly under immense time pressure. There is such a stark, undeniable contrast between a basic candidate and a true top scorer. Think back to our student Alex. Alex is the classic basic candidate. Alex memorizes every fact under the sun and then just dumps a massive generic paragraph about round-robin scheduling without ever mentioning the specific scenario the exam paper actually asked about. The examiner reads it and gives it maybe 2 marks for basic knowledge, but 0 for application. A top-scoring candidate, however, takes a completely different path. They use what we call the PEAL framework, point, evidence, explanation, link. They consider multiple solutions, they analyze the trade-offs, they openly acknowledge the system's limitations, and they heavily justify their decisions with concrete evidence from the text. For instance, if the exam prompt is about designing an interactive user interface for a busy hospital kiosk, the top candidate doesn't just define round-robin. They explain exactly why round-robin is vastly superior to shortest job first in this specific case to ensure the touchscreen remains responsive for the doctors. They discuss the critical trade-off of determining the optimal time quantum size. Make it too short, and the CPU drowns in context switching overhead. Make it too long, and the system feels sluggish. And they justify every single point using the exact details provided in the prompt. This kind of evaluative, tailored thinking is exactly how you craft a beautiful, undeniable 9 out of 9 answer. Let's really lock in these 3 crucial steps for tackling any unfamiliar context they throw at you. 1. Deconstruct. You absolutely must identify the given information and break it down into logical steps. Find those command words and highlight the specific system constraints with your pen. 2. Solve. Systematically execute the analysis using your PEL structure. Make your point, back it up with evidence from the prompt, explain the underlying computer science theory, and link it back to the specific question asked. 3. Evaluate. You have to check your answer for reasonableness and make heavily justified recommendations. It is this 3rd step, the evaluation, that officially distinguishes an A-star student from a B student. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's move into Section 4, the top 3 examiner warnings. We have combed through years of official Cambridge Principal Examiner reports to reveal the massive grade-tanking errors you absolutely must avoid. All right, let's meticulously break down these traps so you never fall into them. Trap number 1, using the completely wrong formula or algorithm for the context given. This happens all the time. The exam question describes a massive overnight batch processing system running payroll for 10,000 employees. But a stressed student reads it and recommends a highly interactive time-slicing scheduling algorithm. That's a total mismatch. You lose the marks instantly. Trap number 2, forgetting to check boundary conditions and edge cases. Examiners love testing this. What actually happens to the CPU when the ready queue is completely empty? Does it just shut down? What happens during a deadlock state when 2 processes are infinitely waiting on each other for a resource? If your written solution doesn't explicitly account for these weird edge cases, your solution is fundamentally incomplete. And trap number 3, providing answers that are not specific to the question's context. I cannot stress this enough. This is the ultimate sin in A-level computer science. If the question asks about managing processes in a hospital life support system, your answer must explicitly, clearly mention the critical real-time nature of those specific medical processes. If you just give a generic answer about a desktop PC, you get 0 application marks, period. To prevent these foundational errors from happening under pressure, We highly recommend using this specific memory hack. Use a visual story method to encode these abstract process management concepts. Transforming dry, invisible theories into vivid, physical visual stories makes your retention insanely efficient. For example, let's talk about context switching. It's a tough concept to articulate clearly. So imagine a literal, physical wooden desk. A worker is sitting there rapidly processing a massive stack of red papers. That represents process A currently running in the CPU. Suddenly, a bright red, high-priority emergency phone rings on the desk. That's a hardware interrupt. Now, the worker can't just throw the red papers on the floor. They must carefully save their exact current place in the red papers and file them neatly into a specific labeled drawer. That drawer is the process control block, saving the state of the process. Only then can they pull out a fresh stack of blue papers to handle the new task. And importantly, the time it takes to pack away the red papers and pull out the blue ones, that's your context switch overhead time. When you visualize these highly technical concepts as physical, real-world actions, recalling the exact precise technical terminology under the immense pressure of a ticking clock becomes infinitely easier. Bringing us to Section 5, the method mark strategy. This is it. This is your ultimate exam room safety net, ensuring that even if one conceptual thread snaps, your entire grade doesn't unravel. Cambridge examiners have issued a massive, repeating alert year after year. Students lose vital marks by simply not showing they're working. Even if your final calculated answer is completely wrong, method marks can and will save your grade. This is an emphatic warning direct from the people grading your papers. In process management, you might be asked a complex mathematical question, like calculating the average turnaround time or waiting time for a set of processes using a specific algorithm. If you do all the math in your head, just write down 14.5 milliseconds, and you made a tiny addition error, you get zero, nothing. But if you take the time to draw out the Gantt chart, if you visually map out the execution sequence step by step, and you explicitly write down the exact formula you are using to calculate those wait times, the examiner can clearly see your logic. Even if you mess up the final division, they will award you method marks because you demonstrated your methodology. Your clear, step-by-step working is your undeniable proof of algorithmic thinking. Never leave it in your head. Put it on the paper. As we wrap up this comprehensive framework, here is your absolute final checklist for evaluative thinking. The next time you are sitting in a mock exam, right before you put your pen down on a massive long response question, you need to pause and ask yourself these 4 things. Did I genuinely consider multiple solutions, or did I just go with my first thought? Did I deeply analyze the trade-offs of the scheduling algorithm I recommended? Did I acknowledge the physical limitations of the operating system's memory allocation? And most importantly, did I explicitly justify my decisions with direct evidence pulled from the provided scenario? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers. You now possess the blueprint to act like that master fashion designer. You know exactly how to tailor your answers perfectly to the context, leaving absolutely no loose threads for the examiners to pull on. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. I want to leave you with this final provocative thought to chew on as you continue your revision this week. In your very next exam, how exactly will you use evidence to justify your edge case recommendations? Really think about that. How will you definitively prove to the Cambridge examiner that your designed a system won't completely crash when the unexpected inevitably happens? Drop a comment below with your target grade for computer science and the absolutely biggest challenge you're currently facing in your revision. Our team responds to every single comment. Like and share this explainer with a study partner who needs to hear this. Ace the Exams, your Cambridge success starts here.